So this is your video for Monday, April 27th. Continuing word problems. We're going to do what's called compound interest today. So first, take a second and look at each of these first things in the top area. How many times a year do each of the following happen? So try to answer these and then I'll go over them. So first one, annually. How many times a year? So in 1 year, annually would happen once. Semi-annually means that it happens twice, 2 times in a year. Quarterly, if I took a year and I broke it up into quarters, I would have 4 quarters. So in a year, it would happen 4 times. Monthly, if I took a year and I broke it up into months, there would be 12 months. Weekly, there are 52 weeks in a year. And daily, we assume it is not a leap year. We would have 365. So compound interest, in the world of investment and debt, interest is added onto a principal in what is known as compound interest. The percent rate is typically given on a yearly basis, but could be applied more than once a year. This is known as the compounding frequency. So we are going to take a look at a problem to understand how this compounding frequency changes how interest is applied. So first we need to know the formula. Last week, remember, we had our growth and decay formulas. This is going to be a new formula anytime you see the word compound. So the formula says A equals P, starts off the same way as the growth and decay. 1 plus, but now, unlike the others, when we take the R, we're going to divide it by this new variable, n, and then we're going to take that whole thing and raise it to the n times t power. Okay, so what do each of these mean? Well, A, again, if you remember from last week, means the final amount that we are dealing with. P means the initial amount. R is the rate. Now with the rate, again, we want to take a percent and convert it to a decimal, just like we did last week. And to do that, we divide by 100 or move the decimal 2 places to the left on our own. T is the time, so all of this is the same as last week, if you remember. And we just have this new variable n now. N is the number of times in 1 year that interest is compounded. Now, to help you out, that is what this top area was. These are the different n values we're going to be using. So you do want to know these words with the numbers that associate with them. So for this first example here, it says a person invests $500 in an account that earns a yearly interest rate of 4%. How much would this investment be worth in 10 years if the compounding frequency was once per year? Now, first thing I want to point out is there is this new word, compounding. Anytime you are meant to use this formula compared to last week's, the word compound will be in the problem. So here is my formula. We are investing $500, so that is our P value. We have an interest rate of 4%. So R, the 4%, we are going to divide it by 100 and make it 0.04. We want to see the investment after 10 years. So T is 10. And the compounding frequency, that's the N, is once per year. So N is 1. So we're going to take all this information down here and just plug it into the formula. Fill in the P that we have, the R, the N, and the T. You're going to take that whole thing and plug it straight into your calculator. So remember, we have that app that we could use on our Chromebook if we want. So we have 500 times 1 plus R was 0.04 divided by N, which is 1. Close the parenthesis like we had on the problem. And then we're raising it to the power of 1 times 10. So there's our answer. Now we are dealing with money here. And when we're dealing with money, if you remember from last week, if it does not tell you where to round, you are going to 2 decimal places. So $740.12. All right, so now next part says how much would this investment be worth in 10 years if the compounding frequency was 4 times per year? And that is known as quarterly compounding. So same investment, our P is still 500. We're still dealing with an interest rate of 4%, which dividing by 100 gives us 0.04. We're still dealing with 10 years. However, our new piece of information, N is now 4. So that means that in 1 year, we are taking this 4% interest rate and we are breaking it up 4 times. So you kind of get a little bit of the interest rate throughout the entire year. Instead of getting the entire 4% at the end, you get a little bit of the 4% during the year. So let's see what happens to the value of the account when we break up that interest rate. So I'm going to use the same formula as before. My P is 500. R is 0.04. N is now 4. And it's to the power 4 times 10. Again, you're going to plug that whole thing into your calculator, and let's see how much money we have this time. So you don't really have to do anything special plugging this in, just type it right on in, hit enter, and we now have $744.43. Now, we didn't start off with that much money, but if you take a look at our 2 final amounts, by taking that exact same interest rate and just breaking it up a few more times during the year instead of getting it all at once at the end of the year, we get it a few times during the year, we did get some more money. So this compounding is useful in terms of how much money you would end up with at the end. So let's try some problems. Number 1, how much would $1,000 invested at a 2% yearly rate compounded monthly be worth in 20 years? So again, you're going to see this word compound in the problems. And that's how I know to use this new formula from today. So we are investing $1,000, so that is our P. our rate, R, we have 2%. Divide by 100, so you get 0.02. T is 20 years. And now N, the number of times in 1 year that interest is compounded. Now the key to give you your N value, that word that tells you what to do, will always be attached to the word compound. So it'll be a nice, easy way to find it in the problem. So monthly in 1 year, monthly, if you need to, you can refer back to that chart from the front. Monthly is 12. So we are going to plug all of this into the formula. And then, just like before, nice and easy, we can type that whole thing straight into our calculator. So we have 1,000 times 1 plus 0.02 divided by 12 to the 12 times t power. Hit enter. And we get $1,491. And this does not tell us where to round again. So nearest cent, like we did on the last two. So the nearest cent would be 0.33. The 8 tells the 2 to round up. So there's your answer. Question 2. Aubrey invested $55,000 in an account paying an interest rate of 5.1% compounded daily. Assuming no deposits or withdrawals are made, how much money to the nearest dollar would be in the account after 15 years? So the word compound is there again, which tells me to use this new formula. We are investing $55,000, so that is our P. We have an interest rate of 5.1%. Again, divide by 100. So we're going to be using for R 0.051. It is compounded daily. So the N value that we should be using daily means 365. And we want the value of the account after 15 years. So T is 15. So plugging all of this straight into the formula. Just make sure that you plug it in correctly. And just like before, once you have it all plugged in, you can go and type it straight into your calculator. So we had 55,000 times 1 plus 0.051 divided by 365 to the power 365 times 15. It says to the nearest dollar, so no change, no decimal, nearest whole number. So that 0.3 means just cut off the decimal and use the number as it is. So 118,188. Final answer. Okay, question 3. Parker is going to invest money in an account with an interest rate of 3.8% and leave it in the account for 7 years. Assuming the interest is compounded daily, how much would Parker have to invest to end up with $880? Okay, so the word compound is there again, which is what's telling me to use this formula. So we have our interest rate, that was the first thing given to us, is 3.8%. Divide by 100. We should get 0.038. We're leaving it in the account for 7 years. So T is 7. If we're compounded daily, like the last problem, N would be 365. And now here's where we need to be careful looking at the question. It says, how much would Parker have to invest to end up with $880? We want to end with the 880. So that is our A value this time. So plugging in carefully. Plugging in all the information we have. We're going to take this big parenthesis and exponent, plug it into the calculator by itself without the 880. Because we have 880 equals P times whatever this number comes out to on my calculator. So typing in, we have 1 plus 0.038 divided by 365 to the power 365 times 7. Like I said last week, do not round your decimals until you're done with the problem. So as annoying as it is, we're going to use that whole decimal right now. So 1.3047 16994. Now, P is multiplying with this number, so we are going to divide this number to the other side. And again, like I said, it's annoying, but you are using the entire decimal. So we get P equals, and on the calculator, we're going to do 880 divided by the entire decimal. And this question did not tell us where to round. So we're going to go nearest cent again, 2 decimal places. So 0.47, and then the 5 tells the 7 to round up to 8. So we have $674.48. Okay, last question, question 4. Paisley is going to invest in an account paying an interest rate of 6.5%, compounded quarterly. How much would Paisley need to invest to the nearest cent for the value of the account to reach $380 in 7 years? So again, the word compound. So here's my formula. So first they gave us the 6.5%. So that is my R. Divide by 100. And they said compounded quarterly. So quarterly means N is 4. If you need to, you can refer back to that chart from the front. Quarterly there is 4. We want the account to reach $380. So that is our final amount. And the time T is 7. So just like question 3, we're going to be solving for P. We're going to do it the exact same way. So plugging in all the numbers, we're going to plug that whole decimal, that whole parenthesis into our calculator. So we'll have 380 equals P times whatever that number comes out to be. So we have 1 plus 0.065 divided by 4 to the power 4 times 7. And again, we're using the whole decimal. 1.5704, 19361. P is multiplying with that, so we are going to divide that entire decimal over to the other side. Remember, we do not round until the end. So 380 divided by the decimal. And it says to the nearest cent, so 2 decimal places, so 0.97. The 3 tells us to stay where we are, so just the 0.97. So 241 point, I believe it was 97. Final answer. Let me know if you have any questions. Either email me or send me a message on Google Classroom, and I'd be happy to help.